So let's take another look and see how to solve this triangle if we're given side A, side B, and angle B. So again, we have an angle side scenario. And to make sure that we don't look like one, we got to make sure that we check for the ambiguous case. So I'll show you how that works now that we've got one of our two special cases out of the way, and that's when no triangle exists. All right, so let's take a look at this, and don't really need a drawing, but if you need one, that's fine. Hopefully you notice we have that good ratio going on already where we have two of the same letter, an angle and a side. And I have side length A, so I'm going to set this up to find the sine of A. And then 19.6 as my side length. Remember, just be consistent on the other side. If you want to say it's equivalent, then you got to start with the angle of the other on top, the sine of that over the length of the side, which is 25.4 inches. And now you can see that this proportion is set up for me to be able to find the angle A that I wanted. So by multiplying both sides by that 19.6, they will cancel out, and I'll get the sine of A is equal to whatever this big old number is multiplied out. So again, I'll go to my trusty calculator and work this out. So I'm going to start with the sine of 68.7, and I'm going to multiply that by the 19.6. And then we had to divide it by the 25.4. And this time, notice we got a number that is less than 1. So we got a number between 1 and -1. We should get an angle. Doesn't look like a reference angle, but let's see how we do this. Remember, to find an angle, we use the inverse. And I'm going to take that answer, and I'm going to hit equals and get 45.967. So rounding that, I would put 46. And then taking those and reversing the order, which is the inverse, right? The number is big, so I didn't put it. It was the 0.7. And we get angle A was 46. And it came out to 45.967, right? Just to remind you. So I'm going to approximate that at 46.0 degrees. And that's my angle A. So now that I have angle A is 46.0 degrees, I want to also remind you that when we're dealing with sine, it is positive in two different quadrants. And if I just found one of my angles is 46.0, right about in the middle, then I'd also get another positive for sine here. And in order to get that, that would be a reference angle here of 46 degrees, which if you notice, that is just going to be the excess from that 46 degrees. So all we ever have to do is take what is called the supplement of that. And remember, 180 minus 40 is 140, minus 6 more would be, that is my possibility for the ambiguous case. Because we know that when we do the inverse, it will only ever give us things in quadrant 1, if you remember going through those. But we also know that in quadrant 2, with that same reference angle, by going 136 degrees, we would also get that exact same number that we had in there, which would give us the exact same answer. So what we need to say is, well, if this is angle 1, is there a possibility for angle 2? That's our question. And so all we ever do is we take 180 and we subtract that first one that we found, which we just found to be 46 degrees. And so if we take that and subtract, we said that we would get a possible angle 2 of, in this case, 134 degrees. Not 36, excuse me. And so with that, I got to answer this question. Is that even possible? Well, remember, they already gave us an angle in this triangle of 68.7. And so if I was to take A2 and add it to the original one, B, do I get something that is less than 180? Because if I do, then that means there can be a third angle and therefore a triangle. But in this case, we know that 134 degrees, when added to 68.7, is too much. It is greater than 180. And therefore, there cannot be two triangles possible. Which again is good news for us, because then that means we don't have to do this. We only have to utilize the things that we've already dealt with, which was the fact that we found an angle of A of 46 degrees. So now that we have angle A is 46 degrees, we got side length A, we got side length B with B, its angle already being 68.7. The only things that we still need are the C's. And since we know two of our angles, we will then take those and add them up. So I will take angle B plus angle A, which was the 68.7, and I will add it to the 46.0 that we got. Adding that up gives us 114.7. So we know to find angle C, we'll take 180 less that 114.7. And we got to do a bit of borrowing, or you can subtract in reverse order like I've shown you a couple times. Either way, you should get this 65.3 for angle C. And now that I know that, I can then use my law of sines once more in order to find little c, or side length C. So in order to do that, I will take one last step over here, and I will use little c over the sine of angle C over my other side that they gave me, which was little b, which is 25.4, over angle B. So I'll take the sine of that, which we've already done once before. Now again, make sure that you know what you're doing here, and you're going to have to multiply by this time the sine of 65.3, so that this all cancels out and we get little c, or side length C, is equal to this number here, which I'll go ahead and punch in my calculator real quick, which is 25.4 times the sine of 65.3. Then I will divide that by the sine of 68.7. And that gives me a side length of 24.8. And we knew that these were all in inches. Now don't forget to make sure that your answers make sense, because side length B was the longest side in this entire thing. It should also have the biggest angle. And hopefully you can see that that is true. Smallest angle, smallest side. And we also knew these two, which this is very close to this, but still shorter, smaller, I should say. Then our side length should also be a bit smaller than the bigger one. Okay, so that is our angle side scenario, that where we only got one, not two triangles, because when we tried to get a second angle, it didn't allow for a third. So you can probably guess what's going to happen in example 3. See if you guys can work it through along with me here. If you want to pause and actually try it on your own, by all means do. Then you can play it back and see if we get the same numbers. All right. So again, hopefully you notice that we have that good ratio of 2 of the same letters, one angle, one side. This time it happens to be A, could be both B's, could be both C's. Either way, that's going to allow us to use the law of sines. But we know that we want to be able to find the alternate to this, which would be angle B. So when trying to set this up, I'm going to end up using, and don't forget, this is an angle side scenario. So we got to make sure that we're looking for the ambiguous case where there could be 0, 1, or weirdly 2 triangles. So when I set this up, I'm going to use the sine of angle B over the length of B equals the sine of angle A over the length of A. And then I can go ahead and multiply over the 39.2 to both sides so that this cancels. And now I'm going to get the sine of B equals whatever number this comes out being. In order to find that, I will have to go ahead and reverse these. In order to do that, we have to do the arc or inverse sine. So I'll be doing the inverse sine of whatever number that is in order to equal angle B. Now, if you want to actually try this all in one step in your calculator, you can. Just be careful. Make sure you use the correct number of parentheses. So let me see if I can do it here. Inverse sine of, we said sine of 61.4. Sine of 61.4, which was being multiplied by 39.2. And then we also wanted to take that and divide it by 35.5. Close off that set of parentheses, hit enter, and it gives me the angle. So if you want to save a few steps, you can do it that way. Just remember your sig figs. In this case, 75.8 is what we are going to say angle B is equal to. Now remember, this is just one scenario because we found the inverse of sine. We might be able to actually come up with another in quadrant 2, which means to get there, I would have to go how far in order to get that 75.8 degree reference angle. Remember, it's always going to be the supplement of that. So we'll take 180 and subtract 75, which will leave us with 105. And then subtract the 0.8, so we get 104.2 degrees. So this would be my possible B2, we'll call it. Since this is B1, our possibility of having a second angle for sine would be 104.2 degrees. So my question is, can I have that as an angle? Well, how do we test? Very simple. Just take the one that they already gave us, angle A, and add it. And as long as that number is what? Hopefully you said less than 180 degrees, then we can have a third angle, which means now we have the ambiguous case, 2 different triangle possibilities. So when I add this up, you can see it is definitely less than 180 degrees. We get this, which actually allows us, since this is angle A, we can take that 165.6 and find angle C by taking 180 and subtracting the 165.6. That would give us, and we're going to call it, because it came from B2, what C2 would be. And so again, we'd have to do some borrowing. So 179, and I'll put my 1 over there as 0.10. And then that would give me 0.4, 4, and 1. A very small angle, which makes sense, but unfortunately, what we have to find. So if that's angle 2 for C, we also want to find angle 1 for C. And again, since we already know angle A, if we add that to B1, which was our 61.4, we get 137.2. We'll then take that and subtract it from 180 to get C1. And when doing that, we get 0.8, 2, and 4. 2 possibilities for each. Now, we found all the angles, the one that they already gave us up at the beginning, angle A, and then we found the first B, and then we said, well, what if there's a second by just finding its supplement? And we took the angle that they were giving us originally and added those up and noticed that it was less than 180. So then we took that and subtracted it from 180 to get our third angle for C2. We did the same thing for A and B1 to get C1. But of course, now we are missing the side lengths for C. We already have the A, we already have the B. Those are given. But now we need to find little c1 and little c2. And in order to do that, we'll go back up to the beginning and use our law of sines with our original stuff that they gave us for side A and angle A, but now for little c1 and little c2. So going back up to the top there, just to make sure that you can see it, I will use this here and this here one more time. And this time I will use little c1 over the sine of angle c1. And then I will use that A, which was 35.5 for my length on top, and then over the sine of A, which was our 61.4. Now I'm going to go ahead and set that up. Same thing over here, but for little c2, which would use the angle of c2, and then our 35.5, that good ratio that we had for that. And then we'll use our law of sines to go through and solve this the same way that we would have with all the other types. And that then allows us to find all the parts for both of our possible triangles. Very labor intensive, not very difficult, but again, lots of little places to make mistakes. But hopefully you guys understood how to tell when there's 0, 1, or 2 of these triangle possibilities. And again, of course, the most difficult is when we have 2, because then we have twice as many things to find. So instead of our normal 3, you can see those 4 there, and then the other 2 right there. So a total of 6 things rather than 3. Twice as many for the 2 triangles. One last type. Not really doing much on this one, but trying to work that mind out a little bit. It says without using the law of sines. Explain why there's no triangle that can exist with this angle side scenario. So do me a quick favor, pause the video right here, give yourself at least 60 seconds to think about this, and then unpause it, and we'll talk about hopefully why you know the answer. All right, hopefully you unpaused it and are now ready to explain to me, even though I can't hear you, why you are not going to look like one of these whenever this is the case. Whether it's 0, in this case is what they're talking about, no triangle exists, or there's the two possible triangles, the ambiguous case. Why can this one not exist? Well, hopefully you noticed the one and only value that I gave you to work with as far as an angle goes, and the side that goes with it. This is what is called an obtuse angle, which means the other two have to be less than that because we know the sum is 180. So in this case, I know that this should be the longest side because of what we just discussed and reviewed. And since 48 is longer than that, we cannot have a side length of little c that yields an angle, capital C, bigger than 93 and still have a third angle. So hopefully that makes sense. Hopefully that's kind of the route that you were going in your head when you paused it and thought to yourself. Otherwise, keep working on this stuff, guys. I know it's a little confusing. Hopefully the overviews you can pause and take notes on, but the key is right here. Just check to see if there's even a possibility. By whatever angle you originally found, you then take and find its supplement. And if that is something less than 180, then you can have a third angle, and therefore you got to use both the original and the supplement in order to find the other two possibilities. Like we saw happen here, and like we saw could not happen here because it was too large. That's all I got for you this one. Tune in next time. I'll see you guys. Take it easy.